Pretty sure I did most of these with every class, but I will run through them one more time just in case we didn't. I may have skipped this one. Emerson runs 5 days a week. Each day he runs fast for 7 minutes and then cools down for 2 minutes. So the distributed property, you can work this problem two ways. You can say he runs 5 days a week, and then each one of those days, this is the number of miles that he runs. He runs two, 7 that are fast and 2 that are cool down. So traditionally, we would say work inside the grouping symbols. So 2 plus 7 would give us 9, and then so he runs a total of 9 minutes, and then 9 minutes for 5 days. 9 times 5 is 45. So he runs for a total of 45 minutes every 5 days. The distributed property says, and up here, Miss Johns uses the fireman example. The fireman's first job is not to put out the fire, actually, but it is to save the people. But the fireman is going to run in and he's going to save the mother. He's going to run in and save the baby. He's also going to run in and save the cat. And then once he saves all of the living things that are in the whatever's burning down, they'll then go in and put out the fire. So the fireman is going to be distributing himself to all the living creatures to save. So in other words, over here, you can, the 5 is the fireman. He's going to run in and he's going to, since the operation right here is multiply, he's going to 5 times 7 is going to give me 35. And then 5 times 2 is going to give me 10. And if you now add those two together, the 35 and the 10, you're going to get 45. And you'll see that you got the same answer using the distributed property as if we didn't use the distributed property. So what that helps us do sometimes is make multiplication a little bit easier. Instead of trying to figure out what 12 times 82 is, why don't you just separate that 82 into 8 plus 2? 80 plus 2. And then you can multiply 12 times 80. Well, 8 times 12, I believe, is 96. And then 2 times, so that would be 960. And then 12 times 2 will be 24. And then it might be a little bit easier to add 960 to 24. So that's one reason why, or one way that you can use the distributive property. The other reason that we may have to use the distributive property is because we may have to multiply an algebraic expression times a number. And since we can't combine what's inside the parentheses anymore, then we are forced to distribute in order to simplify, okay? Because there's no way to combine those two together. Like we can combine the 7 and the 2. To get the 9. So then we could multiply the 9 and the 5. But if we didn't know the value of 2, if we just knew that he was doing 7 minutes fast plus some minutes slow down, and he did that 5 days a week, then we would know he was running at least 35 miles. And then we would find out the rest of it once we figured out how much time he spent slowing down. Okay, so 35 minutes, I said miles, I think, 35 minutes plus 5 times however many minutes he spent running slow or cooling down. So that would be an expression that would represent this if the number of cool down minutes was unknown. So that's another reason why we have distributive property, so that we can still do some simplifying, even if we can't combine what's inside the parentheses. So this is just an example, 1/4 times 12. What property did I use right there? I just remembered that to multiply fractions, I need a numerator and a denominator. So I wrote the 12 over 1, top times top, gave me 12, bottom times bottom gave me 4, and 12 divided by 4 gave me 3. Over here, this is a reciprocal, so this is the multiplicative identity. I multiplied 1/4 times 4 over 1. Those are reciprocals of each other, and reciprocals are inverses. I have 1/4 times 4 over 1. Of course, that's going to reduce down to a value of 1. You can put the value of 1 in front of the t. Don't forget that it's actually a -1, but you don't have to put the 1 in front of the t. That's what we call the ninja one. Distribute the -2. -2 times +2 is -4. -2 times +3 is -6. And -2 times +1 is -2. Since this -2 out in front did not have a variable, all the variables inside the parentheses just stayed the same. They didn't change. Okay, here they wanted you to simplify. And if we couldn't simplify for some reason, it said, right, just tell me that it's already simplified. I can combine like terms. You just add the coefficients. 3x plus 6x gave me 9x. Here I used the commutative property to rearrange them. Did you have to write this step down? No. You can use the commutative property kind of in your head. I've seen a lot of people just underline or maybe draw a little loop right there to show the two that you're combining together, which is perfectly fine. But because we had just recently worked with the commutative property, I wanted to remind you of it. So 21 minus 18, they both have A's, so they're like terms. 21A minus 18A is 3A. And then 31B plus 3B is 34B. I added those together because they're like. You can't do anything further with this because this is an A term and this is a B term and they do not combine. I could combine the 3x squared with the 4x squared. They are like terms. Notice the x squared still stays x squared. When you're combining like terms, all you do is combine the coefficients. The 2x doesn't combine with anything, so it just stays 2x. Down here, they want us to write a symbolic representation for the verbal sentence that's given. So that's exactly what I'm about to do. It says, then simplify, and you indicate the properties. So 2 times, okay, I'm going to be multiplying. 2 times the sum. I'm going to draw the parentheses because that's 2 times a sum means that the distributive property is probably going to be necessary because I'm multiplying 2 times a sum. That's the very definition of what the distributive property is. So 2 times the sum. Now what am I adding together? I'm adding together x squared and y squared. Okay, and that product right there is being increased means plus, by 3 times a sum, okay, 3 times, I need a sum, so I'm going to put my parentheses with the plus sign in front, the sum of x squared and y squared, okay. All right, so certainly can distribute here. 2x squared plus 2y squared. Distribute here, I certainly can. 3x squared plus 3y squared. And then use the commutative property to get 5x squared and use the commutative property right there to rearrange that and get 5y squared. But we should have noticed that we could have also done it a different way. Can we combine anything else right here? No, we cannot, but we can hopefully see that that's just the distributive property with the 5 being distributed. Okay, let's see, let's name the properties from here to here. We did distributive property. Then we did the commutative property. And here we undid the distributive property, but we still did it. Okay. Is this step right here necessary? Probably not, but I think that there's a question on your quiz that kind of looks like this, where it says use the distributive property, and they want you to see what's been distributed and undistributed. So that's why I wanted to be sure and talk about it here, because I think that may be on your quiz. I also want to show you that right here, this whole thing right here and this whole thing right here is just a variable. Yes, it's the sum of 2 variables, but that's just an unknown quantity. It's just a variable. So it's just like a big fat X or a big fat A, or it's just a big variable, a big unknown. And this is a coefficient in front of it. Okay, this is the very same unknown And that is just the coefficient in front of it. And since we have the very same unknowns, we certainly could have just added the coefficients up here at the very beginning and left the variable the way that it is, and we can see that that is just the, if we use the distributive property right here, we would get this, which is the same thing that we got. Why would we want to do it this way? It's just a step shorter. Okay, it keeps us from having to use the commutative property.